Am I audible? So my topic is about making life easier. It's about making your day-to-day life easier every day. And it's motivated by this thing. So you'll notice that the software industry today is hit by many buzzwords. Uh, Whether it's big data, IoT, microservices, AWS, cloud. But in the midst of all these, there's one thing that you cannot escape, and that is writing code every day of your life. So my topic is motivated mostly by making your day-to-day coding easier. Quick introduction about me. My name is Chandan Singh. I've been a developer with Corpus for 3 years now. Most of my experience comes in Scala and Play framework and languages. Lately, I've been doing a lot of Java 8. So this transition from Scala to Java is a bit of another motivation to do this topic. Uh, Also, I've been diving into a bit of Haskell, which also is this. Cool. So my talk is about functional programming, and more specifically, type functional programming. But before I go into what that is and why I'm talking about that, there's a verse of functional programming that goes around in the community, and it goes like this. So once you understand it well enough, you use the ability to explain it to others. And I should have been by this first, but today I hope I am able to break through. So why type functional programming? So in this talk, whenever I say functional programming, I actually mean type functional programming, which is functional programming backed by strong static types, unless I make data space. Whenever I mean FP, I mean type. The reason is obvious. If you look school on a resume, everyone goes around with Java, studying, Ruby, Python. There is very few people who have Haskell on it. That is true. Good enough reason, I suppose. Okay. So before I go into the details, some of the complaints that I got about functional programming, I would like to talk about and discuss them. The first thing I hear is it's came here, and that comes from the fact that we have been taught to think about programming in a certain way. Where programming is just a set of instructions that you give to the computer. It's not about uh, expressions, passing calculations around, and that's why I feel people find it a little weird. And I'll show how it can be not weird just by being a little patient. Also, people say that it's impractical for some reason that I don't understand. People say that it does not work in all situations, but functional programming is a general purpose paradigm. It's not meant for domain specific stuff. It's something that can be applied to every single problem. The project that you're working on today, you can use functional programming to make it better. One of the more reasonable complaints I would say is people say, why do it an object oriented or even procedural works? Why do you change your style of working if it already works and getting results with? I would say to make things better, even if something is not broken, it does not mean that you cannot fix it. You can always make it better. Then people say it's theoretical or academic concepts, and it's meant for mathematicians with white belt, 60 years of age, and those kinds of people who do not have anything to do with the practical software development. But we'll see how that's not the case. And then say that, okay, sure, you say it's a good thing, but no one really does it. Show me the example of people doing it in serious business. So I'll come to that now. So who's doing FP today in hardcore work? These are some of the tech biggies who are doing functional programming every day for running their core services. Facebook US has developed a tool called Haskell, which is a Haskell-based tool for spam for prevention. Haskell, it's a pure functional programming, one of the benchmarks of how we go about how a language should be in the FP community. Twitter is very famous for its switch from Ruby on Rails to Scala uh, some years back. They realized that they used to be running Ruby on Rails, and then they realized that what the kind of problems they have are just too complicated to be solved with Rails framework. So they switched to Scala, and they developed a framework called Chennai, which they now have open source and it's being used by many companies for high concurrency service. Apart from that, LinkedIn also is a LinkedIn is built on Scala and Pay. Microsoft uses Haskell for its key serialization tool. Chef, the provisioning tool, was recently rewritten in Erlang to make it more scalable and more expressive. Apart from that, many banks in the financial tech world, right, they use Haskell, Erlang, and ML, OCaml for running their core services. And also Pockets have been using it for some time now in many projects. Good. So before we move on, I want to share a quote that I read a couple of years back and that actually had a profound impact on my way of thinking about programming. It changed how I think about software engineering. So it's made by this great computer scientist called Leslie Lamport. He's a Turing Award winner. For those who don't know, Turing Award is like the Nobel Prize of computing. And this person wanted for its work in distributed systems. It's like the father of distributed computing. So he said there's something about the culture of software that has included the use of specification. We have a wonderful way of describing things precisely that has been developed over the last couple of years, and it's called mathematics. So that's what functional programming is all about. It's about using maths and algebra to drive your software design. And that's what I'm going to be talking about today. Okay, so now that I have your attention, I would like to tell you what does active bring to the table. A lot of people have a lot of skills. So someone would say it makes your code more mathematical, more direct, more easier to express, declarative. So all those things, it's about the perspective. Someone may have some perspective, someone may have others. What I say is active brings just one thing to the table, and that is good code. That's it. And that's what we all care about, right? That's what you all care about. That's how you earn your bread. So this is the thing that concerns me the most in my day-to-day life. So what do I mean when I say good code? The normal stuff, I suppose. I'm pretty sure everyone knows what good code would mean. So it should be easy to read. It should for anyone joining any new project, they should be able to make sense out of their code. And any real software is thousands of lines of code, a lot of it. Right? When I start working on it, I should be able to read what it is, what does the software do. It should be easy to understand. So just reading does not make sense. I should be able to make a sense out of it. Easy to test, very important. Today's software industry, I suppose we do good on this part, but we could do better. Testability is very important in any kind of software, right? Because this is what drives our business. And if the software is not correct, it's not well tested, or it's not easy to test. I mean, sure, I can be writing anything, but I will still be testing it. But if it's not easy to test, that means I am more likely to miss any kind of testing. So any code that is easy to test is good, and that's something that computer programming is very good at as compared to other languages. And then the other stuff is easy to maintain, of course, and easy to extend. So if I don't just want to be working with the software that I have, I obviously want to extend it. And functional programming brings a lot of modularity to your code, and that makes it far more easier to extend. Okay, so what does functional programming does not bring to the table? I would say it does not bring insanity. What is insanity? Albert Einstein says insanity is doing the same thing over and over again and expecting different results. Right? And I would not agree more. But this is what we do with software every day. We all write code which would qualify as insanity-oriented programming or something like that. And I'll show you an example of that right now. So let's say you have some part of the code, some system which does have some method for module size, let's say. Uh, can have something I don't know what kind of system it is. But when you call this method, what happens? It goes destroy your enemy units. Now you're happy, right? What you wanted is happy. But so you get happy and you get overexcited and you call the method all over again. Of course, now what you expect is it should go destroy your enemy units again. And what happens is it throws an exception. Oh no, I'm out of defense. And this happens every day. We write this kind of code every day. Right? I mean, I don't pass any parameter, I don't expect anything back from that method, but I want it to do something. Have some effect somewhere which is not clearly visible to the consumer or to the programmer who is writing it. And then this happens. And you might say, okay, yeah, the same thing right next to each other, why are the results different? And that's, I suppose, we all would agree that it's not something to do that. Okay, now that I have gathered a lot about what it brings and what it is. So, what is functional programming? I would describe it. Functional programming is based on something called lambda calculus. A big mathematical term, but and which produces a little bit of fear in everyone. I have to learn what calculus is. Most people are afraid of the term calculus itself. So forget having to and that's it. It's enough to scare anyone off. But what I say, it's nothing like that. It's very simple to understand what lambda calculus is, and I'll show you right now why that is. The lambda calculus is based on just two theories, and those two theories. The first one of the theory is that every method or function usually can be anonymous. Does not need to have an identity. So let's say I have a method called ID, which takes in parameter x and returns the same thing, basically identity method. What lambda calculus says is that I don't need the main ID for this method. It says that I can describe it in this way, x to x, this type. Or any other method. Let's say square sum, which takes two integers or any parameters, squares them, adds them to that. I don't need the square sum name or identity of that function. I can describe it as this. I don't need to do anything else. I don't need to have it mean basically. So that's the first thing. The second thing is any function or method can take only one parameter at a time. And you might imagine that that's not really a very useful thing to have, right? Because any code that you write will have oftentimes more parameters than one. So there's a way around that. It's called recurring. What it means is when you have a method which takes more than one parameter, what you essentially do is you compose your functions in such a way that you pass the first parameter to the function, and that gives you another function back, which will take the second or the following parameters to be more functions, and at the end of it, it will be the So if I go to convert this into that form, it would look something like this. So my function is x, which gives a function which takes y, and then I have x and y, and I can do the same as before. So this is what lambda calculus is essentially about. There are other things, other specific things. If you want to go to that, you would need to set up that, but as far as functional programming is concerned, we see the essence of that. So, confused? Lambda calculus is the base of it, but most people would agree that you don't really need to know what it is, or even the term lambda calculus to be able to understand programming. I won't recommend it, so it's a good thing to know the basics, but I agree that you don't need to know it. So I'll present a very much simpler definition of what I make out of functional programming. And this is this. Functional programming is programming with pure functions and no side effects. That's it. That's what functional programming boils down to. I'm writing methods or functions which are pure and they do not have any side effects. They do not go change any state anywhere without being clearly visible. That's it. I'm doing functional programming. And I don't need very specific language, Haskell or Scala, I can still do it in Java. Of course, the language will make everything more difficult to me, but we'll actually achieve that. And I'll show you later about how that can be used. Also, higher order functions. apart from having pure functions and no side effects, we have higher order functions in functional programming. Higher order function is just nothing but any your regular function and method which have the ability to take another function as an input and return another function as a return type. So we get used to having methods which will take a value as an input and return another value as its output, right? Higher order functions can take a function itself as a parameter. So I can pass function along by any other value and return a function out of another function. So that's what essentially it is. And that's it. That's entire concept of FP. Okay, so I've been talking about function a lot, but I haven't really formally described it. So what's a function? This is what function is. And every one of you who has gone to high school in India would probably recognize this sort of pattern. We used to have in some 10th standard textbooks of maths or something like that, which will describe function as something which maps all the values in set x to a value in all some values in set y, and we call it domain, program, range, whatever. But that's essentially what function is. That's it. And this is what function in programming is. So you do not need to understand any more than this to be able to understand that. So like I said, it's a mapping. But one of the most important aspects of it is that every input in x should be mapped to exactly one input in y. And this is coming from the fact when I said insanity, right? When I pass the same, when I do this, try to do the same thing over and over again, it should have the same result every time. So it should not be instant, basically. Okay. So now I would like to make a proposition that functions are inherently typed. I do not believe in untyped or dynamically typed functions at all. There are dynamically typed functional programming languages, but they do not reflect the real world domain as well as type. And so a function is a mapping, right? But your mappings need to be meaningful. You cannot just map everything to everything in the whole world. So mappings need to be meaningful. I'm trying to map something in x and y. My x and y need to be finite. Right? My x cannot be an integer string, some model or whatever, and y cannot be anything. Right? So I can only map some kinds of data to some other kind of data. That is what makes functions inherently typed. And by mappings are basically transformation rules. And those transformation rules have constraints which are dedicated by our domain of software that we are doing. And to capture these constraints precisely, I need types. Very important. So if I don't have types, I cannot constrain my function to do exactly what it is supposed to do. Then my function can potentially do anything if it is not typed, if it is not statically typed. Okay. So quickly, example of integer functions, simple Java code. I want to share an integer. What I do is I modify the integer that comes into as a input param, and I return that. So I still have the job done, but I have done something else as well with that. I have integrated my value with a side effect which is not visible unless you go look inside this method. Right? And that's what makes this function integer. So how would I make it a pure function? Very simple. Just don't do anything. Do what the function is supposed to do. Return, calculate the square on the fly and return that. Don't do anything else. No side effects. Does only one thing that it is supposed to do, and that's a pure function right there. And I can write that in Java, in C, and any other kind of program. Okay, so what other input stuff do we face in everyday programming? We have setters, very commonly talk about in the point. All setters are declared by default because they will not return anything. They will be paid state and you will not know unless you look inside them. Any void or unit method, any in-memory update of variable, if you are updating a variable in base, that's integer, mutation. If you are having a random generator method, that's also. So what's wrong with integer stuff? I'm calling them pure. then you might call them as code. That's how we have been coding forever, and it seems to work, right? Contextual dependence. So whenever I look at inflow code, for example, let's say a void method, I have to store the entire context of its surrounding methods of the state to be able to understand it properly. Uh, Opposite to your function, which takes something and returns something, I only have to understand what it is taking and what it is giving back. But on a void method, which is an employee method, I need to understand exactly what is going on. I have to look into the method to know what's going on and why that method is being called. Obviously, all inflow structure involve state changes, and any state change that's not visible right in your face will be troublesome in the later part of the code. One more thing that I have noticed in programming with those kind of functions is that some of the order of execution of instructions become important. Now, imperative code is a set of instructions being passed to the computer, right? I say do this, and do this, and do this. And oftentimes, the code is structured in such a way that the effect of one method changes the output of another method. So if I shuffle around with the code, I might get different results than what I initially intended to do. And that means I have to be guessing a lot about the code that I see at any point of time. Okay. So what are props? Let's go to let's see some code. So this is pseudo Java-ish code. Unfortunately, Java does not have a wrapper, so I could not write something on the fly and compile it. But let me know if you have any questions about it. Don't go after the syntax or correctness of it, and I will not compile it, obviously. Okay. So we all have been in this situation, right? Where you have a service which injects or takes in other services somehow, depending on the framework how it's done, and it's injected, and it does something. It takes a model in and it mutates the attributes of that model and gives it back to the service or anywhere which is calling it, right? So I named it, let's call it the service, let's call the service code example for the name, and I'm simulating other services like that. So we can go to from all the name, and I am getting component model connection that's called extending volume. Okay, so let's say my service enriches the data on a model which I take, right? So it's very familiar to have. It's very common to have this kind of code, right? I check some condition if that is satisfied. I call another method which will actually go to the setting part, and if some other condition is satisfied, I will call another method and send and likewise. And maybe I reach this state after refactoring from a procedural state, and I will do it all in one line. And then I started methods, variables, and now I have my code in this state. Fairly short enough, short methods, not a lot of private methods, so might actually qualify as. You might not really call it bad code. That's how I it used. Okay. So okay, now let's go into what this method does. So when I call this method, it uses one of the services, let's say, and takes some response back from that service. And if that response is not null, it sets some of the attributes of my main object that I'm trying to enrich anyway. Okay. My second method, what it does is it uses the other service, calls the other service, and what it does is it uses the attributes set by the first method and it passes them on to the service call. And depending on the response of that, again I have to check if the response is null or I have to check for other kind of error scenarios somehow. And then I convert my model that I have into something else to make my newer model, which is essentially the enriched model. Right? And the third method does something like this. Right? So you get the gist of it. So the first problem that I see with this code is when I'm looking at only this part, I do not know exactly what's going on in the first method, the second method, the third method. Now you might say that those methods would be named properly. They won't have generic names, so they would somehow be able to show what they are doing. But what if it's written by someone else and that person is not particularly good at naming variables or methods? So it's quite likely that you will not understand, or you might even assume something that the code does what it doesn't do. Right? So the only way to understand what it does is to go look inside the method and go lambda and understand, okay, this, oh, okay, right? So that's the only way, right? I cannot reason about this code just by looking at this component. Right? The other problem is that, if you notice, my second method uses the parameters set in the first method. So if I somehow, so this seems, at first glance, it seems fairly independent what these two methods are doing. I might as well shuffle these two methods around, and now my code will stop working. Because everything will be null, essentially. Because my parameters are not set, or some other thing is not working. So the order of execution of my methods is very important somehow in this code, which I believe should not be the case. I should be able to call any method at any time and they should be doing what they're supposed to do. Right? Other thing, testing this will be a nightmare. So I have this one single method which does some kind of conjunction, and from the looks of it, you need some at least 3, maybe 4 or 5 test methods to be able to test all the scenarios comprehensively, and then still you might be able to miss. And your tests, what will they do? They will verify that this method was called or not. If you are using optical, you will be doing optical verify that this after this method call this attribute was set or not, and those kind of things. Right? So and writing those kinds of tests is a nightmare. At least to me, I have been freaked out by that. Cool. So okay. So that's one part of the code that I wanted to show. Basically to explain what I mean when I say you need contextual dependency and the order of execution and testability is less ease. Okay. So again, some more pseudo Java-based code just for demonstration purposes. Let's say I have a domain in which let's say I'm building a RESTful API which takes some name as a request param which comes in, and I'm supposed to give back some other name back if the name matches something in my dashboard or somewhere. Okay, so this is my domain. I take a name as a request param, and if that name is valid, I get a 200 OK response with the body. Otherwise, I give a 400 back request. A simple REST API. So how will the code look like? You'll have a controller there, and that's how we structure it in the Java utility story. And we'll have some variation of it in variations of Python or other languages, other frameworks, C#. But similar. So you will have a controller layer, which will basically do something like this, which will return a response back to the caller. But before that, what it will do is it will call the service, check for the nullity of that. If it is null, if it is not null, you return a successful response with content inside that. Other will return a bad request. And your service will, let's say, if your domain is not complicated enough, your service will be very, very easy, and you just call the repository there, and your repository will do the actual getting part of it. Right? Okay. So the problem, first thing here is that if I need to do anything more complicated than just getting values out from my data store or from other third-party API, I need to do a lot of error checks, null checks. Right? So let's say if I was using the response returned by the repository in the service to call another service or another API, the first thing I need to do is this thing null. If not null, then do this. And if I'm doing multiple stuff, multiple null checks, multiple error checks, stuff like that. Okay? So, but this is how we usually code it in the Java code. Right? So I have a So I have tried to solve the same problem in Scala, and I will show how your code to do the same thing becomes far more concise and expressive by if we are using the function constructs. So Scala, so this is the Scala Apple in intelligent. But it will allow me to write a random ad hoc code and it will still compare with the response back. Uh, so what I'm doing here is I'm simulating a DB, the basic in-memory data. So it's essentially has an mapping of first name to last name, and I'll pass the first name as a input parameter and it will give me the last name back if it has if it is valid. But this is what the entire problem is what we saw right now in the Java example. Right? So I started from bottom down, bottom up. What we do is try to get the parameter, try to get get last name out using the parameter that was passed in as request. And you see, this is how I'm defining this function. It takes a request parameter and very importantly, it gives a last name. Optionally, it gives a last name. So right there, and in my code, I'm capturing the constraint that the string may not be present. So whenever a person who reads this code, the first thing that hits his mind is that, oh, it can actually fail. Unlike in the Java example where you are constrained by saying, you might not immediately think that this is something that can potentially fail. Right? And so these are all independent functions that are not being, they are all methods being implemented in the class. And okay, so that's what I do in the repository. And if I have to have something like a controller, what I do is basically take what is given back by the repository and create a response with that. So my create response method what it does is what it takes, optionally it takes the last thing and creates a response out of that. So in the Java world, what you do is check for the validity, right? See if this was returned or not. See if the data store call that I made was actually returned something or not. In functional world, so this option way is more popular, more expensive, but it comes from Haskell. It has come from Haskell into Scala. There are other functional programming languages that will do it in probably some other way. But this maybe type is for how most type functional programming languages handle it. So you have abstraction called map, higher order function on every option. Essentially because an option is a monadic type, and every monadic type will have that have a map method implemented on it. Right. And what that means, what the map method will do, it will go check that if my option has an inhabitant, right? Was it successful? Did it have some value returned by the data store, or if it has, it does your operation on that. And if it does not, it gives you an ability to define a default response back, which is captured here. So what it says that maybe I have a name. If I have a name, I use it to create a successful response, and if I don't, give back a bad request. Very simple, concise enough. So now I have my basic setup complete, and now if I have to create a final response, it becomes just can compose it using the two functions. And this is where having strong static type help. Now the final response, or what my final response would be actually is this. My final response basically takes a request parameter and gives a response type. That is what my entire domain is. I take a request parameter in and use that to give a response type. Right? Since I have this type on it, there is only one possible implementation for this function now. I cannot make this. If I write something wrong, this will not compile. It will not go into production. Project going into production. It will not be pushed because it will not compile at all. And that is this. So I get name from the DB and then create response. This is what you will say. So if you have, if I was to show it in a write a function kind of thing, the way we use write as a tool, you have function x, you have a parameter x, you have f of x as one method, one function, and you have another function which takes which goes from x to gx, let's say. So what I am doing here while creating the final response is basically this f of g of x. This is what it's boiled down to. I'm using, I have two functions with me, and I'm using them to compose my final function. And it reads pretty clearly. If you read this, it becomes very clear what it is happening, right? The name from DB and then the response. This and then is a starter construct. Many other functional languages will do it in some other way. But this is one of the ways to compose, and you have two functions together, you compose them this way. So this is a classic higher order function, final response. It takes two functions and just input parameter and then use it back the final response. So I could give you a demo. So I call the final response with something so for example, let's say my name. Let's say so it gives that at the back, so my name is not maybe I'm sure right? And if I call it with something with a value name, it will give me the response after whatever it is. But it does successful. So first of all, if you have questions, the best time to ask that is when you have them. Don't wait till the end. When you want to just elaborate, if you have discussions around this. Yeah, I mean, it depends on what is that type of this. It's like, whether you look at videos or not, it's kind of but it's composed, taking two functions together and composing one out of three. That, right. So now I've shown that. So you might wonder, so functional programming has been in computer science since the 1960s. It's not new, it's almost 50, 60 years old. So you might wonder why is this suddenly becoming a age? Why is everyone suddenly talking about functional programming? And that is because context. So it's a fact that our processor speeds are flattening down. The processors that we have in our modern computer speeds are not decreasing anymore. We have big sort of but the way we go about increasing the speed of our software is you have multiple core processors. You have 8, 16, everything like that. And functional programming helps us write complex code very easily. So that is how this has become a lot more popular today, but that's not what it only is. It's not only a paradigm that you can use to solve confident solving, not used to write confident solving. It's a general sort of paradigm that it's become popular because of our confidence issues. Why is that? Because of immutability. So all the functional languages, the values, any entity of functional programming languages is immutable by default. So once you have an entity in your hand, you cannot change it. So language so Scala allows you to be impure by keeping around it. But for example, Haskell will not allow you to change any variable once you have initialized it. So you need to describe, put the value in it right when you are initializing it. So what happens because of that the problem of race conditions, right? They disappear right out of it. So if I cannot modify something, I do not have race condition at all, right? So thread safety is inbuilt in functional language. You don't have to write code to make your software safe, right? And I've shown an example of that right now. some more that I wrote. Okay, very simple concurrent code. Let's say I want to perform two operations, and those two operations are independent of each other, but they are being performed on the same entity. Okay, and I have multiple cores in my CPU. So I need my response time or whatever it is after and I'm handling a lot of data. Okay. So one way to do it is make your code make software multi-threaded. And if if you have written multi-threaded program in Java, you know it's very good. Handling features, if you use the feature written in Java, you know that so anything, the maximum you can do with the feature in Java is wait for it, app callbacks, not more. I showed you how functional languages think of features in an entirely different way. Okay. So, simple example, not very complicated, not complicated, it's an example of it. But what I'm doing, so my first operation is basically to declare a number, and my second operation is to do it. I know it's not very complicated, and the real world software will be much more complicated, but just a demonstration of it. The way I will do it is this. So I will define a function which will make an integer and read back a feature of the integer. Because that's where I will for an integer. Right? And to make a code multi-threaded, in Scala is this easy. All you have to do is this. And that's it. Done. Nothing more. You don't have to worry about rest conditions and everything. As soon as you put your code in a feature block, it will become a very code. Same goes with the other methods as well. Right? Okay. So this is just a method utilization. I am not still using them. So the way if I want to use them, if you want to actually calculate those calculations, I do this. I say my result is this. Take the first operation and flip it with the second operation. Since both of these methods become future, what Scala or other functional languages will do is immediately start to different types of both the operations. Now, important thing to note is that both will work on the same input entity. So if you are working in a non-functional language which makes your entity immutable, you have to write code to make it to avoid race conditions. So if my first operation modifies and before second operation has accessed it, I'll get random results, right? Okay. So once I do this, this will give me a future of the two results combined together. So if I want to show you the type of this result in future, this will be something like this. So I'm doing two operations and I'm getting them back in future. And to get your real value out of it is, so the dumbest way to do that is have a callback on the result in future. I will say if when the feature completes, do this, if it's successful, do something, if it's alien, you work on that. Right? But that's how Node.js especially does it, as callbacks. And that's an imperative way of thinking about it. What functional languages will do is this kind of operation. The future, just like an option, is a monadic type once again. So that comes with its own method of mapping and tracking that I go over them. So what you can do is take a value out of the, not take value out of the feature, but access the value and then flat map it to become an option. What that does is it will automatically convert the feature. If the operation has failed for some reason, if it has errored out or given another response or something like that, what it will do is it will automatically create an option out of it. So if it is failure, it will give you none, and if it has been successful, all good, it will give you back some value back properly. So this is the actual point going on. So if I will show you the result of this is how it will happen. Okay. So if you remember, my was 2, and I'm trying to square and do it, so it gives me back. Since my operation is successful, it will give me some value back. Of course, it wraps it inside another option, which you can then use to handle it in whatever way you want, and that's up to the consumer to handle it. So this is how a functional language will do it. If you're writing in a normal interpreted language, I can only imagine the amount of code you need to write to achieve this simple thing. Right? If you're writing this Java, I don't know how to write multiple code in Ruby or Python, but if I'm writing it in Java, this will be anywhere between 20 to 30 lines of code. So moving on. So again, why I'm saying we should be doing typography programming? Because of the things that we have seen so far. It makes things easier. I can reason about my code far more better. I don't have to go look inside every method call. I don't have to carry a lot of context in my mind whenever I go into PHP. So that's what it is, and I'm all about making things easier. Programming is less about, of course, goes with it. If things are easier, if you don't have to think about a lot of stuff at the same time, you don't have to less about it. You only have to care about what you're doing right now. I only care about the function that I'm implementing right now. I don't care about what's happening in other parts of the code. I don't care about if there is a state change in somewhere else. I only think about what I'm doing right now. That requires less effort. And ultimately, develop a habit. If the life is easy, the program is less effort, they are much more likely to be happy and follow about development habits. But let me go with that. If you have any questions, now is the time to ask. Yeah, so having side effects and mutation is a truth of the real world. You cannot always be in a scenario where you will write your functions. What functional programming will ask you to do is push your entire code as far as in one single column. So if I'm generating a random number, if my domain requires me to generate a random number, I cannot escape out of it, right? So that's what I'm required to do. In that case, my code that generates a random number, that will be one single function, and that function will be current. But the other parts of code surrounding it, they will be, if they are using the random number generated by that function, they should be good. So the philosophy here is, if you are forced to do state mutation, for example, forget random number generation. If you are supposed to write something to any others, again, that's a state change. I mean, you cannot make it up your function. You can possibly, but it requires a lot more effort. And but you cannot escape out of it, right? So what functional programming is that restrict your internal code to as less area as possible. Don't let that mutation effect or side effects propagate down layers after layers. Yeah, you cannot escape out of it completely, but you only want to be restricted. Questions? Yeah. Correct. Right. So the question is functional programming intelligence recursion over looping, right? So are you aware of tail recursion? The tail calls? Yeah, tail call optimization. So most functional, the space memory needed for recursive calls of course will be more than when you are looping. But most compiled functional languages have this tail call optimization built into their compiler. So when you are writing, let's say you have managed to write tail recursive code, what the compiler will do is while converting that code into bytecode, it will automatically convert into a loop inside it. So you actual cons of having a recursive code go away there. But that happens only if you manage to write a clean recursive code. If you don't do that, so it's upon the developer to be able to do that. And that's, you could say that's a slight disadvantage. But in general situations, we can build, most of the times it's possible to convert any recursive code into a recursive code. And then compile them commercially, so you don't have any more disadvantages associated with it. No? Thank you. Thanks for coming.